I'm looking at relations and functions, and we've seen that we can graph relationships using a coordinate plane. Okay? And that when we graph these relationships, we can see specific patterns. What we're going to start focusing on are linear relations or straight line patterns or linear functions, because if we think of a straight line will always pass the function test. And so basically linear relations can be identified by a straight line. Okay, so I'm going to write that down. Okay, they can be identified by a straight line. But more importantly, a straight line has two properties. Okay, a straight line has an angle or slope. Okay, so that word is actually quite important, but the angle at which a line exists is going to determine that difference between that line and that line. The other thing that determines a line is the position in space, okay, or position. So this line is different than this line, although they have the same slope, they have different positioning. And what we're going to look at is specifically their vertical positioning. And we're going to be a little bit more concise about the positioning a little bit later on. But essentially, these are two things that describe lines. Okay? Any two lines can be differentiated by their angle or slope or their position. And if we know the position and we know the slope, we know exactly the line that we're talking about. So here we have relationship between looks like the weight of Jolly Ranchers and the cost of Jolly Ranchers. Okay, so if the relationship is if we buy 0 grams, it costs us nothing. If we buy 100 grams, it costs us 55 cents, and etc. Okay, and we graph this line here. We're going to get this relationship where we have 100 grams, 200 grams, 300 grams, and over here we have 1500 grams as graphed as that dot there. So we have these data points. Our dependent variable is cost, the independent is weight, or our input is weight, and our output is cost. So we can probably come up with some kind of equation for this as well. So relationships exist as a word relationship, as a table of values connecting x's to y's, and also as a graph. And this graph, when we graph it, gives us this linear relationship. And this is what we're going to now focus on. That linear relationship then has a specific slope to it or angle to it and is located at a certain position. And what we're going to actually look at, and it's easy to keep track of, is it's our initial position, which is when x is 0. Okay, that's usually going to be, for now anyways, a convenient place to look for the positioning, because if it starts up here at x at $5 and goes up with the same angle, these are two different relationships. Okay, so this one specifically starts at 0 and goes up like this, and the slope works out to be 0.0055, and in fact the slope of the slope units here actually seems like it's going to be $0.0055 per gram, because it looks like if we divide 55 cents by 100 grams, we get $0.0055. Okay, and it looks like that's our rate. So this slope seems to have some relationship to the rate. Okay, so let's compare the ratio change to the domain range. Okay, so the ratio change here is going to be seen here. So, and we're going to show the ratio of change on the outside. So we add 55 cents for 100 grams. Okay, and it looks like the ratio of change is consistent. We add another 100 grams, we add another 55 cents. And this is really important to be able to see the changes on the outside here. We add another 100 grams, we add another 55 cents. Here we added 1200 grams, and here we've added $6 and it looks like $6.60. Okay, so this ratio of change looks consistent. It's kind of hard to see, but if we divide $6.60 by 1,200, we're going to get the same as if we divided 55 by 100 grams. So the ratio of change looks like it's going to be plus, and I'm just going to use the 55 cents, plus 55 cents for every 100 grams. And when we talk about ratios of change, we can use a unit rate or a unit ratio. We're just going to say plus $0.0055 for every 1 gram. And this is where it looks like it connects to slope. These things seem to have some kind of connection with each other. Okay, so this is definitely something we want to look at. And this slope seems to represent the unit rate, or the rate per 1 gram. And so if we were going to write an equation for this, maybe we can write it this way. So we're going to start with, in fact we gave you the equation, the relationship is the cost is equal to $0.0055 per gram times the number of grams. And so in function notation, we're going to write like this. F of x, the output is equal to, for every gram, we're going to multiply it by, for every 1 gram, we're going to multiply it by 0.0055, and we're going to times that by the number of grams. So we can see if this works. I can plug in 100 grams. 100 times that number is going to give me 55 cents. Yeah, that looks like it's right. That's going to give me the correct output. Okay, so there's our function that we're going to that we can use to describe this. So we have this function described in words here. This is described in a table, described in a graph, and we come up with the equation for this relationship.